Thank you for the introduction. Can you enable screen sharing? Okay. All right, so let's get this open. You can see okay? Perfect. So yeah, as Naomi mentioned, my name is Lua. I'm now starting my second year as a postdoc at NYU Langone Medical Center. And until 2020, I was still at CUNY, and I just moved a couple blocks down the street. So it doesn't feel like much has changed, but also everything's changed. And that's, I suppose, like part of what I'm going to talk about, like the trajectory from not really knowing what you're going to do as an undergraduate and having sort of vague interests and seeing them sort of like come together to write a dissertation and sort of, figuring out what your direction is from there. So I'll talk a little bit about that. And something I want to say too is I've incorporated some more formal sort of description of my research, but also I have every now and again some sort of informal stops to talk about the actual experience of all of this, because that's not really a perspective that we often get when in science talks. And so I want to encourage everyone to jump in with questions. I'm happy to answer along the way. My introduction to research. So as Naomi mentioned, I went to undergrad at Trinity College Dublin in Ireland. I'm originally half Irish, so that was sort of my incentive to go there. And I first started in a natural sciences program, so it was very broad. It was a 4-year undergrad program. And the first 2 years I did mathematics, physics, biology, and chemistry. They were pretty advanced, and the goal was that when you got to the end of your second year, you sort of had a choice to specialize in one of 14 different like sub areas. And my first choice was neuroscience, and I got into it. So for years 3 and 4, I was studying neuroscience. And here there's something kind of specific that I guess I didn't realize going into the program, was that my interest in neuroscience came from actually a book called Emotional Intelligence by Daniel Goleman. I don't know if anyone knows that book, but that's all about sort of understanding emotion through the lens of the brain. And so to me, neuroscience was this sort of bridge between more psychological human aspects and understanding the science of the brain. And going into this neuroscience program in undergrad, I sort of had this like disillusionment, because I realized, wait, we're not really talking about psychology anymore. And so it was super science focused. We did neuroanatomy, neuropsychology, neurophysiology, neurogenetics, everything in and between, every single aspect of biology of the brain you can imagine. But there was very little sort of trying to actually acknowledge that the reason we're studying all of this is because it's what makes us human, and it's what makes us function, and it's what gives rise to the mind. And this was my perspective on why I was doing this. So it was kind of tricky to figure out where to go from there. There we go. Okay. And so to sort of summarize a little bit what my interests were, and I didn't know this, when I went into undergrad, I was sort of just like, I like neuroscience because I thought it was this bridge between the worlds of psychology and philosophy and science, and these, it kind of brought together a lot of my interests, which at the time were super broad. And then I soon learned that what my interests were could be classified under the C word, or consciousness, which, is more accepted in Europe, but it's still not a sort of very valid research area. It's like, this no man's land between neuroscience and philosophy, and various other things like psychology and so on. And so to me, there were many different perspectives I could take on this. I was interested in, how people's perceptions are different, even though they're looking at the same situation. I was interested in how people's emotions and like personality influence how they experience the world. I was interested in memory and, all these sort of various topics, but wanting to take a very neuroscience perspective on it. And so I felt pretty lost leaving undergrad, because basically my program didn't incorporate any cognitive neuroscience. And so my interest didn't really fit into any subfield. I had some pretty terrible meetings with faculty members who I'd say, like, these are my interests, where should I go from now? And they were like, well, you don't have any psychology background, so you would have to start from scratch basically. And or, you know, like, that's not real neuroscience, you know, just all these like very close-minded perspectives on. And I mean, luckily enough, and this is where I'll get to that part in a second, I had a sort of serendipitous moment where in the last few months of my undergrad, a friend of mine was in like the neuroscience society at my college, and he called me at lunchtime and just said, hey, there's a talk happening at the Neuroscience Society and I think you'll like it, you should come by, it's starting in 20 minutes. And so I showed up sort of like not knowing at all what it was going to be about. And it was a talk about the cognitive neuroscience of consciousness. And I was just like, honestly, like jaw dropped, like the whole talk. I was just like on the edge of my seat, like this person, or like, here is one person representing an entire subfield that's studying exactly what I'm interested in. And I was just like, it was just like in shock, honestly. And I went up and spoke to the speaker afterwards and told him I was really interested in that work. And I followed up with an email and he invited me to come to do a research internship in Brussels at his lab, which was at the ULB, the University of Brussels. And so I ended up a few months later going to the lab. I thought it would be this sort of formal thing where I'd be assigned to a project and taught how to do things and things would be expected of me. But obviously that's changes a lot depending on the lab. And in this lab, I was totally free, left to my own devices, told to just, you know, shadow as many people as I could, get introduced to as many methods as I could. And honestly, that's like the best learning experience I could have had, because there was such a vast array of topics being studied in his lab, but all more or less related to the topic of consciousness. And so I got a really good introduction, like broad overview of everything that was going on. So I stayed there for 6 months. This was from like September to February 2014. And I was applying for grad school to start in September 2015. So it was right at that time. I was writing all my grad school applications. I applied for a Fulbright scholarship, which I didn't get. I was applying for master's programs as well as PhD programs. And I applied to 3 programs in the US, Columbia, NYU, and CUNY. Clearly, I was very New York obsessed. And I got into, well, no, actually, so I was called for an interview at CUNY. I happened to be in New York at the time for a couple of months, unrelated to grad school. I was an au pair, actually, so I was a nanny on the Upper West Side. So very different experience of New York. And while I was there, I got this interview at CUNY and I was waitlisted. And when I found out I was waitlisted, I was like, well, what am I going to do? You know? And in the end, you know, I did get a spot, but I still wasn't super convinced that this was for me. And to me, it was, you know, some people have various reasons for starting a PhD. I don't think mine was very clear or concrete. To me, it was just about, I'm really interested in this thing, and this thing is super abstract. And the only way to really do this is to be in academia, because I didn't see myself continuing these sort of like vague conceptual interests about cognitive neuroscience at a company, or at least I couldn't, I couldn't see anything that would sort of serve these interests. So I sort of went into a PhD by default. And I think like I'm a real commitment phobe, and the idea of spending 5 years on this was terrifying to me. So I think what got me to actually accept the position was like, you know, I don't owe anyone anything. And if I don't like it after a year, I can just drop out and like, whatever, they're paying me. So, but you know, of course I got pretty into it. And at that point it felt like I couldn't leave. And so I stayed. And okay, so arriving at CUNY, I was in the behavioral and cognitive neuroscience program in the psychology department. That program is a rotation program, which means that you are supposed to spend some time in at least 2 labs and which is what I did. My first semester, I was in Jin Fan's lab at Queen's College. That wasn't a good fit in terms of working style and expectations, and it was really difficult. But I did analyze a data set from scratch there and wrote up a manuscript, and I was like, why aren't we going to publish this? And he was like, no. I was like, I don't understand. Anyway, it was a great introduction because I did a lot in a short amount of time. But then I went to Elizabeth Chua's lab at Brooklyn College, studying memory and specifically meta memory. And this was a little bit closer to my interests because metacognition is like awareness of one's own mental states. And obviously this topic is very related to the topic of consciousness. And so it was really nice to be studying something that felt a little bit closer to exactly what I wanted to do. That worked out too, but Dr. Chua's lab did not have funding. So I sort of had to find a third rotation last minute. And I ended up rotating in Dr. Tony Rowe's lab. And it was sort of like unclear whether his lab had funding, but he sort of put me to the test and told me, you know, let's see what you can get done in 3 months. And if you can, you know, if it's good enough, then we'll find funding for you, which in retrospect is really kind of a difficult challenge to put on a first year student who has almost no experience in neuroscience. But anyway, I was thrown in the deep end. At this point, I'm going to go into a little bit of what I studied. One thing I want to mention is that, yeah, the first 3 months, I basically had to learn to code from scratch. I had zero coding background. I had done some tutorials online, but more as like fun. And here I was being asked to code analyses in Scratch in R and to code, you know, experiment files in C++. C++ in particular is extremely inaccessible to a beginner. So that was difficult, but I do believe now in retrospect, that's kind of the only way to learn with coding, is to be given a sort of a task that's sort of out of reach and figuring out on your own how to get there. It obviously helps to have people who already know what they're doing, but I did not have that luxury. So, okay. Maybe before I go into the research part, I can see if anyone has any questions or wants to hop in. Or
how was the coding? I know you said it was difficult, but like when did you start feeling comfortable with it? Like how many months, or I don't know if it took weeks. And do you see yourself like using it to like other things? I don't know if you're into technology, or I don't know. Like, do you use it applied to other things as well?
So the first response that comes to mind is that when I wrote code that ran for the first time, I like almost cried because it's so gratifying when it finally something runs, and it's something as stupid as like adding two numbers together and you're like, hallelujah. And I would say like the learning curve was really steep, but within like maybe 4 or 5 months, I had some comfort and I could do like simple things without thinking about it too much. But you know, like that was in 2015, that was 7 years ago, and I'm still coding all the time. Like I code every single day, and I still don't consider myself proficient, but it's more sort of a level of, you know, certain types of tasks you get really good at, and it's like it becomes second nature and you kind of know how to do it. And something that I found very gratifying is that when I started at my new lab at NYU, nobody was using any of the coding languages I'd used before. And so it was sort of a case of like learning 2 new languages. And at first I was terrified. I was like, oh my God, here we go again. But like, there's so many things that are similar that I surprised myself at how quickly I learned them. But I was like, oh, actually, you know, these are super transferable skills. And I think I would feel comfortable if it came to it taking a data science job, because I think, you know, from just using it all the time, it's not so much that I feel like I could already do what would be asked of me. It's that I have confidence now in like my learning abilities with coding, because I've seen, you know, several times now learning a new language or a different type of tasks or a new type of analysis, once you sort of get that muscle trained, it's much easier to learn down the line. So yeah, it's kind of hard to time how long it took to feel this way, but maybe like within a year, I felt like pretty confident with it.
Thank you.
Yeah, you're welcome. Okay, so to give a little bit of background on what I was doing in Tony Rowe's lab. So I've mentioned that my research interests are about consciousness, but this term is extremely vague to a lot of people. A lot of people use it in different ways depending on the type of field that they're in. In my case, and I think I mentioned this a little bit before, I've always been interested in consciousness in the sense of how is, like, what influences or determines my conscious experience. So, you know, I'm sitting in my living room right now, there's some flowers next to me. My conscious experience is made up of, you know, the visual scene of the screen I'm looking at, the smell from those flowers, the light that's coming in, the time of day. There's all these different components, and these are also influenced by how I'm feeling at this current moment, who I am, where I'm at in my life, what's happened, you know, how tired I am, all these different factors. And so to me, that's the study of consciousness is trying to understand at the level of the brain how somebody experiences the world subjectively. And of course, that's going to change from person to person. And in order to study that in neuroscience, one way to look at that is to look at dissociations between subjective and objective experiences. So by objective, I just mean, you know, what is quantifiably happening in the world, and subjective is how am I experiencing it? And of course that might change. And for the same exact objective situation, I could have different subjective experiences from moment to moment, and me and another person sitting next to each other might have very different subjective experiences. And so there are two types of situations in which there is a dissociation between subjective and objective perception that I'm interested in. So in illusions, for example, what we have is a situation in which somebody is having a subjective experience in the world, but there is no accompanying objective information out there that lines up with it. So for example, having the illusion of like seeing a familiar face in a crowd, you might have that subjective experience very strongly, but objectively the person is not there. And there's, you know, many different types of illusions. Some of them are unisensory, some of them are cross-modal, so they involve several different sensory modalities. But so that's one side of the coin, is subjective experience without objective information. And the other side of the coin is something that we call unconscious perception. And in that case, there is objectively sensory stimulation happening, but the person is not experiencing it subjectively. So in blindness, for example, or cortical blindness, there's information that is arriving on the retinas, and then information is being sent to the brain. But for some reason that we don't yet fully understand, these people do not have a subjective experience of the visual world. And to them, you know, the world is black and nothing is going on. And so these are the two types of situations I was interested in looking at: unconscious perception and illusions, because in both cases, they tell us something about what's missing for consciousness to arise, for the actual subjective part to arise. So these are sort of the two approaches that have been used in vision. Blind sight is the situation I just described, where visual information does reach the brain, but for some reason, some of these people don't have any conscious experience of the visual world. And in visual illusions, it's the flip side. So you do have a subjective experience, but it doesn't correspond to anything real happening in the world. So most theories of consciousness are based on these types of studies and make conclusions about what's happening in the brain, either what's missing in blind sight or what's happening in visual illusions that shouldn't be happen, that doesn't normally happen. And together this information converges to sort of help us understand what consciousness is made up of in the brain. Okay, and so here I have some sort of more specific questions for touch. So when I entered the lab, Tony had an idea for a project that he wanted to do in the lab, and specifically related to this situation of blind sight. So blind sight is a clinical phenomenon. So in people who've had lesions to their primary visual cortex and the occipital lobe, a small proportion of them have this condition of blind sight where, despite the information arriving in the brain, because V1 is damaged, the primary visual cortex is damaged, they don't have a conscious experience. And so we wanted to know, okay, there are some clinical cases of this also happening in touch, where information is being conveyed from the peripheral nervous system and from the skin to the brain, but for some reason, these people can't feel anything on that part of the body. So for example, there's a woman who lost sensation from her elbow down on her left arm, and information was still reliably recorded from the brain, but she could feel nothing. So what's missing here? Is it a specific pathway? Is it a specific type of mechanism in the sensory cortex that's not working? So that's sort of the question that we were asking. And also, in the case of tactile illusions, what's happening in the sensory cortices that might be involved in these illusions? Because that might tell us something about what's needed for something to be conscious. Okay. All right, so, so as I mentioned, starting up on this project, I had to learn C++ and R in the first 3 months in the lab. Another thing that I learned straight off the bat was how to use TMS. So transcranial magnetic stimulation, it's a form of non-invasive brain stimulation where this sort of wand here is held up against the scalp. The wand administers a magnetic pulse, which enters the underlying cortex and can basically interrupt any ongoing activity in that part of the brain. There are different types of TMS wands. There are round ones that disrupt activity over a greater patch of the scalp versus these figure-8 type coils that administer a very focal disruption of activity. And so I was using this with the goal of disrupting activity in primary somatosensory cortex, so S1, because we know that S1 is the sort of the primary receiver of inputs from the skin, of tactile inputs from the skin. And so we wanted to see if we disrupt activity in S1, can we still, are we just going to disrupt the subjective experience of touch? Are we going to interrupt all types of tactile processing, even unconscious types? I also learned how to use EEG. So EEG, electroencephalography. I don't know how many of you need an introduction, but basically electrodes are placed all over the brain in at specific locations across the scalp. And electrical currents traveling across the scalp coming from the brain are recorded and with very good temporal resolution. So with about 1,000 samples per second. And so one can combine EEG and TMS together, but it is not easy because TMS sends a huge magnetic pulse into the brain and EEG is recording current, and current of course is induced by the magnetic pulse. And so you get this huge spike in the data, which has nothing to do with the actual brain activity. And it's just coming from the TMS machine itself. And so most of the first year I spent in the lab after collecting this data, we got the behavior to work, which was great, but most of the first year, I was just trying to clean up that data. And in the end, I never cleaned it up. Like there was nothing we could do. We did clean it up, but we didn't find any significant results. So I ended up just publishing the data from the TMS alone. Yeah, so the first project in the lab was called NumSense. I've given you guys a brief introduction, and I'm going to go into a little bit more detail about the scientific background on it. Okay, so I'll first talk about this project briefly, then I'll talk about my project on synesthesia, so the sort of flip side of the question looking at tactile illusions, and yeah, and we'll go from there. Okay, so what reasons do we have to believe that tactile awareness or the ability to subjectively feel touch relies on S1? So I was saying with TMS, we were targeting S1, and this sort of gives the motivation for why we were targeting this area. So we know from clinical studies that people who've experienced lesions to S1 lose the ability to detect any touch. So like I said, this woman who had who had lost sensation from the left elbow down, what we could see was that S1 was disrupted, and specifically the part of the somatosensory map that's in the somatosensory cortex that is responsible for receiving signals from the arm. And so we know that there was disruption there, which is good evidence that S1 might be involved in tactile detection. There's also a series of studies in the 90s looking at how TMS attenuates touch detection when it was administered over S1, which is a second piece of evidence. And a third piece of evidence is that certain tactile illusions co-vary with S1 activity. So for example, in phantom limb pain, so subjects who are patients who've had an amputation for whatever reason in a limb often feel the sensation of an itch on the toe of the leg that was amputated, for example. And some really clever studies have shown that in the somatosensory map, in the somatosensory cortex, the area of cortex that normally was responsible for innervating the toe is being activated, and that activation co-varies in magnitude with the intensity of the illusion, which again shows that something's happening in S1 that's directly related to the subjective experience, because these amputated patients, they don't have a leg anymore. All that you're seeing is this activation in the cortex that's corresponding directly to their subjective experience, even though there's no physical stimulus. Okay, so that's the motivation that we had for looking at S1. Now, numb sense is the name of this. It's the equivalent of blind sight and touch. And so it's this condition here that was documented in this patient that I was describing before, who was numb from the left arm down, from the left elbow down. What you can see is that where the lesion was corresponds exactly to S1. And what's really interesting about this subject, which I haven't brought up yet, is that despite not being able to detect anything on her arm, if she was forced to guess, so forced to guess, for example, am I stroking the arm in this direction or this direction? Or am I touching you on the wrist or on the forearm? If she was forced to guess, then her accuracy was 90% plus. So she was clearly processing some information from the arm, since she was getting the answers correct 90% of the time. She was clearly processing some information, but it was not conscious. So this is a form of unconscious touch perception. And so this was documented in a couple subjects, not that many, but this was motivation enough to try and basically replicate the phenomenon with TMS, because with TMS, it's non-invasive. So you don't need someone to magically just have a lesion exactly in the area that you are trying to target. And it's causal, right? So if you disrupt activity in that brain area, and the person immediately loses the ability to do a certain task, then you have very good reason to believe that that brain area is responsible for that task. Contrasted with other methods like EEG or fMRI, these are more correlational methods that give you sort of ideas for where to target with a more causal method like TMS. Okay, and so the question here was, since we know that disrupting S1 with TMS causes the loss of touch detection, the question is, can other forms of unconscious touch perception occur independently of S1? So if you still disrupt S1, is something happening that could explain this numb sense behavior that this woman was displaying? So can an S1 independent pathway support unconscious touch perception? So our hypothesis was that interfering with S1 activity with TMS would suppress conscious touch perception, but leave unconscious touch localization above chance. So localization here is a task that we use to probe unconscious touch perception. So we're not asking people, we're asking people if they can feel something, yes or no, but then we're asking them to guess and it's a task called forced choice discrimination, where subjects have to give a response in every trial, even if they don't know, and even if it feels like guessing. So we asked them to guess, did you feel something on the left finger or on the right finger? So let's just, I'll show you a little bit more what the details are. So just for the TMS here, this is an example on 4 subjects of very creepy brain or head reconstructions that we got from their MRIs, and just sort of plotting where on the brain we ended up stimulating them. There's a whole procedure for localizing where to stimulate with TMS that I'm happy to go into if anyone has questions. But essentially you locate motor cortex by looking for twitches in the hand, because when you stimulate TMS, if you're over the hand area, you're going to see twitches in the hand. And then from there, you can localize the somatosensory cortex, which is just posterior because it's in the post-central gyrus, whereas the motor cortex is in the pre-central gyrus. And since the somatosensory and the motor map mirror each other almost perfectly, that's sort of a trick to get to the somatosensory cortex. Anyway, so what's happening in the experiment itself? So each subject has 2 electrodes, one on the index finger, one on the ring finger. And these are tactile electrodes that deliver a tiny electric shock, sort of the equivalent of on a cold winter day when you open a car, it's like the static electricity. So it's very, it's not painful at all. And we kept the intensity basically at threshold. So when people can barely feel the stimulus at all. And in each trial, there would be a 75% chance of TMS occurring. So a TMS pulse would go and subjects would feel touch either on the left finger or the right finger. And in every single trial, they would be asked, did you feel tactile stimulus, yes or no? And was it on the index or ring finger? And they would respond in every single trial. What's important here is that we had catch trials, right? So in half of the trials, there wasn't a tactile stimulus at all. And this allowed us to measure signal detection theory measures, which allows us to basically say how well a person is able to detect a stimulus when it's present and to correctly report its absence when it's absent. So that's what the sensitivity D prime measures. And all it does basically is take the hit rate. So when they said, yes, I felt something when there was a stimulus, and subtract the false alarm rate. So when subjects say, yes, there was something, even though there was no tactile stimulus. So the prediction is that if you're really good, then your D prime should be high, which is the case in the no TMS trials. So people were very good at detecting if the stimulus was there or if it wasn't when there was no TMS. But there was a huge decrease in D prime when TMS was administered. So subjects were almost, so 0 is when people really can't tell the difference between a stimulus being present or absent. They weren't at 0, but they were much closer to 0. This was not a novelty. This was just reproducing results we already have from the literature showing this, which is great. What we were really interested in is what's happening with the discrimination. So are they still able to correctly localize what finger it was on, even though they're clearly saying that they're not feeling the stimulus in many of the TMS trials. We did want to show here that the tactile criterion didn't change. So the criterion is a measure of bias. So how frequently people, how trigger ready you are, basically. So whether or not there's a stimulus, you might have a tendency to respond yes much more frequently for whatever reason, because you just have a bias that's inbuilt. So we just showed that the TMS didn't change the bias, because a lot of people like to interpret blindsight type studies by claiming that it's a change in criterion. So here we're just showing that that wasn't the case. Okay, so tactile location discrimination. This was really our true hypothesis test. So here we have the percentage. So in the trials where there was no TMS and subjects reported that they felt the stimulus, subjects were at ceiling. So people were, they were performing almost perfectly. So if they did feel the stimulus, then they could tell with high certainty which finger it was on. Now, what we're specifically interested in is when there was TMS, and specifically the trials where people said they did not feel the stimulus. So these are the unconscious trials, right? And so here, what we see is that the TMS unaware trials, the average, I think, was about 66% accuracy, but importantly, this was significantly above chance. So just in a simple one-tailed t-test or two-tailed t-test, we showed that this was significantly above chance. So if subjects were reporting completely by guessing between the index finger and the ring finger, then they should be at 50%. So this shows us that there is some information that's being somehow passing through the brain despite S1 being totally disrupted with TMS. Okay, so conclusions on this study. So this was the first demonstration of TMS-induced numb sense. And it shows that parallel S1 independent pathways might underlie this type of unconscious tactile processing. We don't have a sense for what those pathways are, but the fact that subjects can do this tactile task without S1 suggests that some other pathways are somehow processing this tactile information in parallel. So just to sort of give a tiny bit more background, we know from the neuroanatomy that almost all information from the skin that via the thalamus is relayed first to S1 and then to S2. There are a couple of recent studies that are sort of trying to revise this framework and argue that there's a parallel processing scheme in somatosensory cortex where both S1 and S2 receive inputs and then engage in extensive crosstalk to process that information together. And so given our results, and given these other studies that show that S1 and S2 can process information at the same time, if we disrupt S1 and S1 is responsible for conscious touch perception, then that doesn't discount that S2 could also be receiving the information and processing it unconsciously. So that's sort of the working model that we had for understanding these results. Okay, does anyone have any questions before I go on to the second project? Okay, so I'll continue. Okay, so just to give sort of some background of the point at which I was in my PhD at that moment. So I learned to do EEG and I had focused on touch perception. It was sort of looking like I wouldn't be able to publish an EEG study. My advisor was really set on that EEG data set getting out, even though I was doing the analysis and I could clearly tell there was nothing there. So that was really difficult to convince him to sort of let's move along without these results and maybe something comes up in the future, but for now we need to get these results out. So that's what ended up happening. So we published just the TMS-induced numb sense results. I think I finished collecting this data set in early 2017 and the paper came out in 2021, so 4 years. And I think it went through like 4 journals maybe before being accepted and like who knows how many rounds of reviews. So it was not so fun to get that paper out. And so at this point, I sort of had to think of the general sense of my direction of my dissertation. You know, I think some people go into the PhD and their attitude is more to get like super specialized in one topic. And, you know, an obvious next step for this numb sense project would have been to do it in the fMRI with TMS. And that's one route I could have taken, or try to get some other sort of neuroimaging data to confirm this hypothesis that S2 was responsible. And that's something I could have done, but I think as a person, I'm much more of a generalist. And I sort of felt like I want to dip my feet in as many things as I can and really sort of get a sense for what I'm interested in. And there was a lot of studies going on in the lab looking at multisensory interactions. So how, say, vision and touch interact. And Tony, my advisor, had done some significant studies on synesthesia several years before. And I had sort of brought it up with him that I was really interested in that. And so that's sort of the direction I started going in. I want to say, like, it's so easy to look back and feel like I knew what I was doing and where this was all going to lead to, but that's not the case. Like, that sense came in the last 2 weeks of writing my dissertation. You know what I mean? Like, it's not, it's like the hindsight bias thing. Like, I had no sense of like, okay, you need to like get a dissertation up and running now. I think that really happened like 1 year before I finished, where I was like, okay, how do I make this all make sense together? And, you know, I'm only going to show 2 of my projects now, but they're pretty far apart. But somehow I like, let's squash these all together. And this is a nice little packet with a bow. But, you know, for some people, it's a lot easier. Their projects are more directly related. For me, that wasn't the case at all. And, you know, if you're clever about it, that you can make that work, and, you know, it's fine. But yeah, I don't think I was being very strategic when I was like, let me go in this vastly different direction in like year 3 of my PhD. And, but, you know, there we go. Made it work in the end. And so, yeah, like I said, oh, sorry, is there a question? Or no, maybe just someone unmuted. Yeah, so like I said, I was interested in various topics, but I was also interested in getting more experience with different techniques and sort of getting a sense for how these different techniques were done. And so that's how I started getting into multisensory illusions. And more specifically, so here, I use this picture to sort of convey, for example, when you hear a mosquito buzzing in the air and suddenly you feel itchy, or you know, when you hear nails on a blackboard and you get this like sort of very visceral sensation in your spine. These are forms of multisensory illusions where one stimulus in one modality causes the illusion of a sensation in a different modality, and they're clearly induced one by the other. And understanding how these occur is also, I think it's interesting for many different reasons. It's interesting because it again tells us something about the mechanisms of conscious perception, even when they're dissociated from physical stimulation. They also tell us something about how the senses talk with each other. So how, you know, multisensory interactions take place in the brain. And they give us insights into like alternative forms of consciousness. So in the case of synesthesia, that's something that, you know, non-synesthetic people have a hard time understanding. But I was very interested, you know, there's this really interesting quote, and I think it's Henry James, that says, you know, if your theory of consciousness can't explain, you know, weird forms of consciousness, then what's it really doing? And we have this sense that there's such a thing as normal consciousness, but we all have weird consciousnesses in our own very unique ways. You know, I have a really pronounced sense of smell, and I can go into a room and I can tell like who's been there, and I can, you know, it's really weird. And lots of people don't have this experience, but I don't consider myself abnormal. And I think my sense is that if we do want to understand something like perception and consciousness, then we need to sort of cast a wide net and really try and understand even the most unusual cases, because they're still informative for a general understanding. Okay, so how do multisensory influences alter the subjective experience of touch? So in this case, I was interested in sound touch synesthesia. Sound touch synesthesia is a very rare form of synesthesia. It's not very documented. What is documented about synesthesia are the more common forms, which I'll talk about in a second. But for someone who hasn't even heard the word synesthesia before, it's often described as a sensory crosstalk, where one sense is talking to another. And it's very well documented for like creative, like artists and musicians. So for people who like taste color or can smell sound, and, you know, it's also documented for psychedelic experiences where people start to see colors associated with different smells or different flavors. And so it's relatively common. Grapheme color is the most documented form of synesthesia, where people associate colors with numbers and letters. And it's estimated to impact like 4% of the population. My view is that there's many, many, many more than that, but that's somewhat controversial, but we'll come back to that. So anyway, sound touch synesthesia is when someone feels touch in response to sound. And it can be something like you hear a car horn and you feel an itch on your right knee, or you hear the sound of a cat meowing and you feel like like someone just punched you on the back. You know, it can be various forms of specific and precise, but also yeah, like much broader, sort of like I feel like a tingling on my hip or something. But they're very reliable. So when people hear the same sounds over and over again, they're going to have the same sensations co-occurring with them. One girl, and this always struck me as so amazing, reported when she listened to a certain song, the sound filled her hands with broken glass sitting in a slimy dishcloth. And to me, that's so like such a visceral image, that you could have something so specific evoked when you listen to one song was really like fascinating to me.
Sorry to
yeah,
I think there's a question.
yeah. Oops, I didn't mean to do that. What's the question? Or is it in the chat?
Hi, I was curious because in terms of like when people hiccup, they say it's contagious. So is that a sense of, you know, correlation to what you're talking about?
Huh. I've never really thought about that. There's one type of synesthesia that's called mirror touch synesthesia, where if you're looking at somebody else who's feeling and you see their body being touched in some way, then you'll feel that sensation on your own body. So in that sense, touch is contagious in that type of synesthesia, but that's a little bit different in the sense that there's this whole like empathy thing going on and this like social aspect. So like typically synesthesia is described sort of like within one's person experience, and it's crosstalk between their own senses. Yeah, I think the definition could be broadened to encompass that type of situation where you have one sensation from observing it in someone else, because that is like vision to whatever it is that you're experiencing. But yeah, typically that wouldn't fall directly under the definition.
Okay, thank you.
Yeah, you're welcome. Okay, so just a little bit of background on what studies had been done up to this point on synesthesia and sound touch synesthesia specifically. So in two studies that my advisor had done several years prior to my entering the lab, they had studied sound touch synesthesia in a person who had had a stroke and who developed synesthesia after the stroke. So after a stroke, there's a really intense period of plasticity where neural connections can grow and a lot of things can change sort of exactly around where the stroke was, because the tissue is trying to repair itself. And what they found in this subject was that there was increased activity in S2, so the secondary somatosensory cortex, sort of like I showed in the previous project. There was increased activity in S2 in response to sound. So when this person listened to sounds through a headphone, what they measured in the fMRI was that S2 was responding. So what's happening is that she's listening to a sound and the touch cortex is responding. And not only that, in a subsequent study looking at DTI tractography that looks at the white matter connections between various areas, what they found was that there were this higher density of connections between the A1 primary auditory cortex here in red and the somatosensory cortex here in green. And these yellow tracks show the denser connections in synesthetics compared to controls, or in this one synesthete compared to controls. So to me, this was pretty good, a pretty good basis for a hypothesis that something could be happening in somatosensory cortex that would directly explain this illusion of touch, right? Or a sound-induced illusion of touch. So the question was, does synesthetic touch rely on sound-activated somatosensory processes? And also there was this other really cool fact to me, which is that when you look at the auditory cortex, it's organized using a tonotopic map. So lower frequency sounds sit at one end of the cortex, continuing up to higher frequency sounds. And so there's this very reliable tonotopic organization. And of course, the somatosensory cortex is organized somatotopically. So the homunculus represents adjacent parts of the body along adjacent parts of the somatosensory cortex. So this kind of gave me the second hypothesis that something would happen according to frequency, and that we might see changes. If the somatosensory cortex was responding to changes in frequency, then we might see changes along the body. So that was sort of my working hypothesis. So to collect some data for this, I first wanted to do a behavioral study. The reason for this is that I sort of wide-eyed, idealistically imagined that I could just get a bunch of sound touch synesthetes into the lab and test them, and was sort of met with the harsh reality that sound touch synesthetes don't walk the streets, and certainly not those of New York, and that it's very hard to get them actually into the lab. So I started recruiting online. I recruited everywhere you can think of: Reddit, Facebook, weird forums, the American Synesthesia Association. I was just mining every resource I had to try and find people who had this form of synesthesia. I ended up recruiting 19 people. I recruited like 80, but only 19 actually completed the task. I first screened them for synesthesia with a consistency test, so playing various sounds in various orders and asking them to report how intensely they felt something and where in their body. And if they gave the same responses for 3 times the same sound was played, then that was sort of my inclusion criteria for having them in the study. I played 13 sounds from very low pitch, 100 hertz, all the way up to very high pitch, 15,000 hertz. And for each sound, I asked them, can you feel this sound, yes or no? Where do you feel it on your body? And they would click somewhere on the body. How intense is the sensation? And then please rate it on all these qualitative scales. So hard to soft, wet or sticky to dry, rough to smooth, hot to cold, sharp to dull. Just to sort of get a sense of mapping out what are the consistencies, what are the reliable systematic correspondences between sound and touch in synesthesia. Because there was really nothing out there in the literature that had done this at all. You know, that's been done for grapheme color and for other more common forms of synesthesia, but for this form, there really wasn't anything like it. Okay, and so here are the results. So this is a visually heavy slide, but I'm going to walk you through it. So on the left here is the body. This is the body that people were clicking on. Anything that was on the back body or on the faces, I converted to clicks on this one body. So I could get an average for where people were feeling sound. And each color here represents a different frequency of sound. So the low frequency sounds are red, going up orange, yellow, all the way up to 15,000 hertz, which is represented up here. And so these are the main activations across all presentations of the sound. So each subject heard each sound 20 times, and there were 19 subjects. So this is across all subjects. What we see is this really reliable pattern here, where low frequency sounds are felt lower on the body compared to high frequency sounds that are felt higher on the body. I couldn't believe my eyes when I saw this plot. And I produced this plot, I think, in April 2020, and I gave my dissertation in July. So yeah, I mean, just to reassure anyone who's like at the phase of writing your dissertation, I was still running analyses up until like a few weeks before like submitting my dissertation. It's perfectly normal. And even though it feels like you should panic, you shouldn't, because this is what everyone does. And let me just turn on the light quickly. Okay, and so we didn't see any correlation here on the x-axis, but on the y-axis, so just from low body up to high body, we did see this very strong a very significant correlation between the frequency of sound and where people were selecting on the body. These are the correlations for intensity and the 5 different qualitative scales. And so some of these showed some strong correlations, but that's less sort of what I'm interested in. So what sort of conclusions do we get from this, right? So like I said, we have this frequency map in auditory cortex, and we have this somatosensory map in somatosensory cortex. So interim conclusions, the frequency of sound predicts the location on the body of tactile sensations in synesthesia. The frequency of sound also correlated with hardness, sharpness, and roughness. And the adjacent locations of the sensations induced by sounds suggest that they rely on areas with a somatotopic organization, namely S1 or S2. So my working hypothesis was that S2 was probably responsible because S2 has a somatotopic map. We know that S2 and auditory cortex are very densely connected, even in the normal population. So this might underlie why we're seeing these really strong correspondences that are organized according to frequency and coming out as according to this body map. So the idea was that one-to-one anatomical connections might underlie these very systematic relation patterns that we're seeing in synesthesia. Now, of course, at this point, I had a promising data set, behavioral, and I wanted to collect neuroimaging data to support my claims. I collected my first subject on March 11th, 2022, and the lab closed the next day. I think it reopened like 3 months ago. It took like almost 2 years to reopen. So what was I going to do? My goal, this is the first subject I collected. My goal was to collect EEG and optical imaging. I'm happy to give an intro to optical imaging if people don't know about it, because it's not a very widespread technique. But the goal was really to sort of, I thought it would have been really neat to show that there's increased S2 representations in response to sound in synesthetes. That would have been a really neat story, but of course I wasn't able to collect that data. I was lucky enough to have enough data for 4 dissertation chapters though. So it was just time to start writing. I also had an additional constraint, which is that I'm an international student and my funding was running out. So my funding was over by the end of August. Therefore, the latest time I could deposit was September 15th. And it would have just been like such a headache trying to find more funding and putting up with the lab that I wasn't super satisfied in and everything else. And so I started writing. And by that, I mean, I manically tried to wrap up my analyses and started writing bits and pieces here and there. I would say, I'm trying to think of the timeline again. I think I genuinely started writing maybe end of May. I spent all of June writing, and the last 2 weeks before I submitted to my committee my dissertation July 19th, and I think those last 2 weeks before is when I started my general intro and my general discussion. I'm not recommending this. I work well under pressure. I just say this just to say like it's possible. Like you will be insane when it finishes, but it's possible.
So when did you apply for a postdoc? That's my big question.
Why?
No, when did you start?
Oh, okay. Yeah, I'm about to get to that. I think it's on the next. All right. So yeah, I defended my dissertation in Zoom, August 2020. Meanwhile, okay, so April 2020, I had vaguely, I'm a last minute person. Like I don't plan things. People were like, you should apply for postdocs like a year before you defend. And I was like, sure. And I didn't do it. I think I applied to one, but I sort of half-heartedly, and I wasn't really sure I wanted to. And I was starting to keep a working list of people whose work I was interested in and who corresponded vaguely sort of like geographically to where I wanted to be. And I started sending out some emails, and I had like some contacts of people who had vaguely said that maybe you could do a postdoc with me, and that, you know, they literally never responded to my emails. So I was sort of, at that point, I was a little bit like, we'll see what happens. I don't really know. And there was Biuha at Langone was somebody who was on my list, and I was really impressed by her work. I was a little bit intimidated by her work because she was doing stuff on conscious perception as well, but she had these really sort of advanced computational models, and she used all these fancy techniques, and she was just very impressive. Like, I saw her give several talks, and so I was really putting off emailing her because, you know, imposter syndrome, and I was like, why would she be interested in me? At my friend's encouragement, I did send her an email in April. So I had already started writing. And it was a very sort of general email, like, I really like your research for these reasons. This is what I'm doing that's related. If ever something comes up, let me know. And like, you know, there was nothing advertised on her website or anything. I just like cold emailed her. And this is where like it's very magical in the sense that she emailed me back an hour later saying, you know, your email piqued my interest. I'm actually looking for someone right now. I haven't advertised it yet. Will you give a talk in my lab in 2 months? And I was like, what do you mean give a talk in your lab? And I was terrified. But actually, it was the timing of 2 months and having to give a cohesive talk about my research a month before submitting my dissertation, I'm actually incredibly grateful for, because it got me to finalize the story 1 month before like sitting down and writing for a month straight, which I don't think I would have done, at least this formally, if I didn't have this to look forward to. And so in June 2020, I gave a talk in her lab meeting on Zoom, and it went pretty well. I was sort of shocked to hear people ask questions because they seemed genuinely interested rather than because they were putting me to the test, which I think a lot of grad school feels like. And so she sort of gave me the heads up that she was interested in hiring me, but NYU had this hiring freeze so she couldn't use any sort of like internal grant money to hire me. So it would all depend on whether she got a grant down the line. And so basically between June and December, so like 6 months, I was just on hiatus. And she asked me, you know, I understand if you find a postdoc somewhere else, but like, you know, please try and let me know if something comes up. I'm going to do my best to hire you. And anyway, in December, I did find out that I was going to get the job because she had got funding. And I started 2 months later in February 2021. And I'm studying pretty much almost the same types of questions that I did during my PhD. Just a super brief overview, because I don't want to go into too much detail here. What I study is basically taking into account that the brain at rest, so when the brain is not actively processing information from the outside world, so if you're, say, like mind wandering or just staring at a blank wall and not paying attention to anything in particular, the brain is not on standby. The brain is characterized by really rich and complex patterns of endogenous activity. So spontaneous fluctuations in various networks of the brain that are defined also by connectivity patterns. And so then what happens when information does come into the brain, when the brain is processing sensory information, we have, and this is what I characterized in my old lab, we have waves of stimulus-driven activity. And in my old lab, that's what I was interested in. And I characterized those for touch perception. But what I never took into account is how does this exogenous activity interact with the ongoing fluctuations in the brain. And so that's what I'm studying now, is looking at these interactions. When a stimulus comes into the brain, what state is the brain in at that point? And how is that going to modulate how information is processed down the line? And in turn, how does that change our perception? Yeah, so that's a sort of very brief overview. At this point, I'm finished with my presentation, and I'm happy to take any questions. And thanks so much for listening, everyone.
Yeah, thank you so much for presenting to us and going so much in detail. I think of all the inspiring scientist sessions we've had, this was the easiest one for me as an undergraduate student to kind of keep track of and actually hold on to the whole presentation and understand each piece of information you presented, because you started like all the way from the basics of what consciousness is all the way
Right.
to your second part. So it was definitely very helpful the way you put it out. Thank
Great,
you.
I'm glad.
Yeah. Does anyone have any general or specific questions they want to ask? You can unmute yourself or put it in the chat if you have anything. Okay, so while people are processing or thinking of questions, I actually have a question. So you mentioned during your first part of the first project that you worked on that there were 4 years of going through different journals to get published. So was that because the EEG data that wasn't conclusive, or like was there any other specific reason for that, for it not being published right away?
It's no, and unfortunately, like I would say this is not the 4 years, but I would say it is like pretty standard to go through several journals before, being published. The 4 years, it counts like the year of trying to get the EEG data to produce interesting results. It includes preparing the manuscript. It was the first manuscript I was writing from scratch. So that probably took longer than it would normally take, or than it would take now, I guess. And then there were just incredibly long wait times between reviews, and we sort of got far along in the review process with one journal, and one reviewer just really didn't want it to be published, and so we had to start over from scratch again. And then another reviewer asked us to collect a control data set, so we were back to data collection again. And so it's just, all these setbacks, it just takes a really long time.
So it's a normal thing.
I think this was a particularly long version of what is normally a long process. Yeah.
Very interesting. Okay.
Yeah. I mean, I have another paper, and that was all done in like a year and a half, which is a lot faster, but I would say, we were invited to contribute to a special issue. So there was somewhat more assurance of being published. So yeah, that was kind of maybe a special case.
So there's also another question in the chat. Mm-hmm. Did you take any gap years before going to grad school?
Yeah, so like I mentioned, I took that one gap year where I was a research intern in a lab, but I had really like no responsibilities, and that felt more like, I mean, I wasn't taking time off, but it felt very fun because I could really sort of really follow what I was interested in, and I was in a new city, and it was really cool. And then in January of that year, I moved to New York. My partner at the time was in New York, and I found this au pair job where I was nannying, and I was sort of like, it'll be 6 months of working and having fun in New York, and then I'll move back for grad school. And little did I know, I got into grad school here, and so I ended up staying, and here I am like 8 years later. So that was not part of the plan, but that's where my gap year led me, basically. Yeah.
I think Kristen also has her hand raised if you want to ask.
Yeah. So sorry, I joined in like kind of late, but I had a question about the frequencies and the people with the synesthesia and where they felt it. And I was just wondering, is it only people with synesthesia that feel sounds in that manner? Like, because like when you said it, honestly, I wasn't that surprised, just because for me personally, like when I hear bass, like I feel that if it's loud enough, I can literally feel it in my stomach, depending on how loud it is. And then if I hear like a higher frequency, I feel it in my head and I feel like nauseous. So okay. I was just wondering, but like it's very particular frequencies. It's very particular volumes.
Right. I mean, it sounds like you have synesthesia. So just to sort of respond to your question, this is not abnormal at all that I talk about this and someone who's listening is like, hold on, I feel that. And I think this uncovers a really, really important thing about synesthesia that we haven't yet totally acknowledged, which is that a ton of people feel synesthesia, but they don't know how to describe this phenomenon, or they don't know that it's abnormal in some way, and that synesthesia is some sort of continuum. And the reason I say that is that a lot of the people who I did manage to get into the lab to come and who ended up coming into the lab to sort of do a general synesthesia battery type of thing, where I would test them on like lots of different types of synesthesia, would discover with me when I was doing the sound touch test that they had it. And they were like, oh yeah, I mean, I've always felt this, but I didn't know it was a form of synesthesia. And I think of all the types of synesthesia out there, it's the one that we can relate to the most, because sound and touch are pretty similar anyway. Like they're vibrations either on the skin or on the eardrum, right? And they're the same types of receptors either in the skin or in the ear that are processing this type of information. And the cortices are very close in the brain. So to me, that also makes sense that these things would be related even in like the normal population. But I think it says something more broadly about how normal and synesthetic perception are not two different things. They're part of the same sort of continuum.
Awesome, thank you.
You're welcome.
Hi, okay, so I also have one more question. This is more general. I've been wanting to ask this since like the beginning when you first started talking to Naomi, but so you transitioned to many different labs. You came from Ireland, and then you came to CUNY, and then you went to NYU. So there must have been many good advisors that you've met who have helped you progress in your career, but then there may have also been many bad mentors, or not bad, but people who were not rooting for you as much as the rest.
Mhm.
So were there any discriminating behavior that you experienced that was kind of directed towards you, and how were you able to overcome that if you did experience that?
That's a hard question.
Yeah.
I think like my sense from the start was that I'm on my own in this. Like coming out of my undergrad and being told by so many people like what is this weird thing you're trying to study, like that doesn't exist, and like there's no place for you, basically gave me a sense from the start like either you're going to do this totally on your own or you're not going to do it at all, like you're going to shift to something else. And so, and like also the way that the academic system is set up in Ireland is that you really don't have a lot of one-on-one time with faculty members. You know, you get like huge auditoriums with like 200 students, and there's no such thing really as office hours. And so you might email with someone about like logistics of an exam or something, but you really don't get to know your professors at all. So it's not like I had someone to turn to and be like, please, like, can you give me some advice? There was one professor in my undergrad who studied something totally different. He studied genetics in Drosophila. But he just had sort of like a personal interest in consciousness and the types of questions I was interested in. And we ended up having some interesting conversations, and he ended up sort of encouraging me a little. But I think, yeah, having the sense that like you're on your own maybe gave me some sort of like drive and independence that I wouldn't have had otherwise. And especially arriving in my PhD lab where, you know, I felt like I had to be my own advocate. That sense like continued and maybe like further, where I sort of like had to stand up for myself to a certain extent. And I was really, really lucky because there was a postdoc in the lab who I was good friends with, who really like, in all intents and purposes, was my advisor. Like he read all my drafts, he helped me practice all my talks, like he helped me debug analyses and code that wasn't working, like everything. Like I owe my sanity and my dissertation to this person. So, and I think that's really beautiful. Like, I think to me, like, that's what academia is about, is that you like help people selflessly because someone helped you in the past and because you're paying it forward, you know? And like, I think that makes me much more aware of like the difficulties of mentorship and the importance of of being a caring mentor now. And like, I don't have a ton of experience with that, but, you know, I do have an undergrad research assistant. And I try to be aware of that as much as I can because my experiences were, for the most part, really difficult.
Would you say, just from, you know, saying that you're on your own and being more independent, is there any specific advice that you would give to undergraduate students or students taking a gap year who are trying to pursue a PhD, who are a little more dependent and don't have that mindset yet?
I think the advice I would give is like, go for the things that make you feel passionate and like excited. And if you're following that, then don't be scared to try things. I think like the main difference I see between myself as a starting PhD student and myself as a starting postdoc is like, I know that it's okay to try something and to admit like, I actually have no idea how to do this, I'm just trying it. And like, that has given me so much freedom and so much confidence to be like, yeah, of course I'm gonna mess up on this, I'm just learning. But I think there's like such a sense when you start a PhD that like, you should know things already. Like, you are the student here. You are here because you're like gonna learn these things. So it's okay to mess up, and it's okay to spend 2 years doing an analysis that you're not gonna end up ever looking at ever again. Like that, I think that part is the part that is like the steepest learning curve in a PhD, is like that like realizing that the only way you're gonna learn is by messing up like a million times before. And like coding is the perfect example. Like, how many times have I spent like weeks trying to figure out how some function works, only to realize like, oh, it's like this tiniest, stupidest thing was wrong. And like, boom, now it works. But like, you have to go through that to like learn. Like, that's just how it goes, you know? But I don't know. I mean, like, I think for me, like talking to people who actually take your interests seriously and help you brainstorm how to implement those into practical sort of like research ideas, that's the hardest part. Because I remember having so many like areas of interest, but actually like formulating them into a research question, that took a lot of training, and it took reading a lot of papers and having a lot of conversations with people. And I think that's like the biggest thing I learned in my PhD, is how do you translate sort of like being excited about a topic into saying like, okay, what is already known and what is not yet known, and therefore what can you possibly contribute to this area?
Thank you. That was really good advice, and then a good overall summary of, you know, everything you had to discover and learn through your PhD career. I have more questions, but I think I'm going to stop there just for the sake of time. Does anyone else have any questions that they'd like to ask before we end? Yeah, because we went way over time.
Yeah, sorry, I just realized the time. I was like, oops.
Yeah, no, it's better that way than to end short.
Yeah, and you know, if anyone has questions, like feel free to email me. I'm more than happy to, yeah, to take any questions.
Okay.